If some program requests raising privileges, it should do this in the secure desktop. The secure desktop is not protected by the Ctrl-Alt-Delete key sequence. However, it's well designed, so it's difficult to overlook. The security desktop is primarily to minimize the risk of spoofing programs in a dialog box. This security only raises the level. On the internet, there are programs that emulate the window asking for additional privileges. The secure desktop is also designed to draw our attention. It's hard to overlook such a window. Let's think about the purpose of user account control. Windows users, unlike users of other systems, are accustomed to the fact that they work in administrative accounts. This has a lot of historical justification. We log on to the administrator account and we work on it the entire time. It's difficult to imagine how Microsoft, while ensuring the safety of users and without compromising their reputation or the brand of their systems, would have to convince all users to suddenly begin to use standard user accounts. All the more, many programs do not run correctly if they do not have additional privileges. This is due to what we talked about a moment ago. Companies producing or creating and testing this software use the administrative account on a daily basis. The programmer wrote the program, which ran on the administrative account. The tester logged on to the administrative account and found that the program operates correctly. No one became especially involved in testing whether the program will also run when we take certain privileges away from it. The user account control mechanism is enabled by default, and its configuration is reduced to a single dialog box. This is probably the ugliest dialog box in all of Windows. In Windows Vista, this configuration was more extensive. In Windows 7, it boils down to the fact that we can say how often we want to be asked whether we agree to attach the process to an administrative token. You've probably noticed in Windows 7 that this question is asked less often. Windows 7 designers noticed that there is no sense in asking such questions if, for example, we run a trusted program, such as a part of an operating system whose operation is determined in advance, and it's known what a given function is doing. If we run a system component that's digitally signed by Microsoft, it should automatically receive administrative privileges because it does not pose any threat to the integrity of the system. This simple fact has caused the number of questions to be greatly reduced. Let's see then how the user account control mechanism works. If we're still using a 32-bit operating system, we'll also see how the mechanism allows running applications that for some reason require additional privileges. We'll see how the user account control mechanism automatically virtualizes processes. In testing Windows 7, run the command line. Although we're logged in as a user having administrative privileges, we've not asked for granting an additional token. So the cmd.exe process runs with the standard user privileges. Let's go now to the System folder. We're in the Windows folder. Without any problem, we can read its contents. Let's try to write something in this folder. An error message is displayed, informing us about denial of access. By default, standard users do not have the rights to modify the content of the System folder. If we now run Windows Task Manager and find our program cmd.exe, it turns out that we can virtualize it. The virtualization option is automatically run for processes of third-party applications. As far as CMD is concerned, it's not automatically enabled because we should not virtualize this program. We do this solely for the purpose of demonstration. If a third-party application wants to perform an operation, just as we did a moment ago, it will be automatically virtualized. Let's see what changed. Now, the same file in the same folder can be created. Was the privilege to the folder changed? Rather not. Maybe this file wasn't even created. Let's check. As we can see, the file exists and the fragment of some text is saved within it. The question arises, where is this file? In order to answer this question, we run Windows Explorer, but we run it from this process. Because the parent process was virtualized, the newly run process will also be virtualized. We see that a new button appeared, which normally we won't find in Explorer. When you click on this button, it turns out that we can see our file. So what happened? Note the location of the file. It is no longer a system folder. It's a user folder. All operations performed by the virtualization process are captured by user account control and redirected to a folder where they can be performed. This is a solution which is solely intended to enable older and poorly written applications to run. This is why virtualization is not available in 64-bit Windows. Microsoft's assumption is that the transition from 32 to a 64-bit platform is the equivalent to the transition to a higher quality. Here there should be programs written so that they work properly with standard privileges and do not have to be virtualized. Unfortunately, the only program that fully incorporates the integrity level mechanism and user account control up to now is Internet Explorer. This same Internet Explorer, running on Windows 7 and on Windows XP, offers completely different levels of security. In Windows XP, it's not run in protected mode. In Windows 7, it's run by default. How was it done? In one of the earlier lectures, we said that the Internet Explorer process runs on a low level of responsibility. Therefore, it cannot modify anything that is located at higher levels of responsibility. If the user would like to perform such an operation, the proxy IEuser-exe is used. To use this proxy, we have to explicitly agree to this.